Hey, good morning and welcome back. Today we are starting our new chapter, chapter 12, talking about circles. We're going to get one more chapter in quick before spring break. Just a reminder, if you didn't complete the chapter 8 test from last week, please get that done. I'll be working on getting those in the gradebook today and tomorrow, and then our quarter ends at the end of the week. So we want to make sure we have everything turned in by then so we don't have any failing grades that are bringing us down in Skyward, okay? So also one thing, if you're using the notes, I made a mistake. This is actually chapter 12. It says chapter 10 up here. So chapter 12.1. So let's go ahead and start with some vocabulary here. So if we look here, it says we want to write what the word is. Is there some sort of symbol we can put? And then finally, it has the definition. So this is a two-dimensional shape made by drawing a curve that is always the same distance from a center. Okay, so that's kind of confusing, but the word I'm sure you guys are all familiar with, it is circle. Now in our case here, this circle is around the center point of O. So our symbol, there's our circle, kind of looks like an eyeball, and the circle is O. Okay. Now, our next one, it says a segment whose endpoints are the center of the circle and a point on the circle. So it goes from the center to the edge. Okay, so like OS here. And this is what we know as the radius. I'm guessing lots of you have heard this before. Radius goes from the center to the edge. I could do like OS and put a little segment sign over the top. So from O to S is our radius. Our next one, it says a segment where it is the distance across the circle and goes through the center. So it has to go through the center and it goes from one side to the other. So like T to A here goes through the center point of O there. So that is, I could write it like this, TA with a segment marking. That is known as our diameter. Remember, the radius is half of the diameter. Diameter is all the way across the circle through the center. Radius is from the center to the edge. Okay. Now our next one, a segment whose endpoints are on the circle. So it could just be like our diameter there, but it just has to go from one part of the circle to the other. So like up here, US. Okay, US, that is known as a chord. Okay, so that is a chord, CHORD. The next one, notice we were doing segments. This next one's a line. A segment has endpoints on the ends. A line has arrows on each end. So a line that intersects the circle in 2 points. This is known as a secant. And if we look up here, so it's a line that hits it at 2 points, like WR here. Do you see how it goes through once, twice, keeps going? So line WR, remember to put a line WR over the top. We just put an arrow on each end. Okay. Then our next one, this is a line that that intersects the circle at exactly 1 point. Okay, and this is when it's tangent. So that's a T at the front, tangent. So tangent to the circle means it has to hit it at just 1 point. So right here, like CB, it hits it at 1 point. That point would be Y, and that point will be our next one. So right here we have CB, line CB. The point where it hit is Y. That is known as our point of tangency. And if we look at our definition here, it says the point where a tangent line intersects the circle to which it is tangent. Okay, so the point of tangency. Okay, now the next one, a circle has blank degrees. I'm hoping many of you have heard this before. You know it's 360 degrees. Now this next one you might not be sure of, but just think about what semicircle means. Semicircle, that's going to be 180 degrees. All right, so down here at the bottom now, we need to tell whether the line, segment, or point is best described as a chord, a secant, a tangent, a point of tangency, a diameter, or a radius. Okay, so if we look here at circle C, remember the C is in the center. This is circle C. We can decide what are each of these. Now, for whatever reason, it kind of It's not perfect. That should be over the top. These first two are segments. That's a line. It kind of got blocked. I'm not quite sure why it's showing up like that, but we'll make do. So number 1, CE. So it starts at the center, goes to the edge. That is known as the radius. All right, our next one, EG. Goes from one edge to the other edge through the center. That is the diameter. Now our next one, AD, is a line, so limits our choices. AD, it only touches at this one point B. That is going to be tangent. Remember, point B, that's our last one here, is known as our point of tangency. All right, our next one, HF. So HF, it's a line, and it goes through at 2 points. That is our secant. And finally, the last one, CG. So from C to G. Be careful. Some of you might be tempted to say it's going to be a chord because we haven't used that, but CG is actually the radius again. So now on the back, we have a few problems we're going to solve using some rules about tangents. Okay, so this first theorem says if a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency. So what we mean by that is if this line here is tangent, then the radius and that line of tangency, they are going to form a right angle, right? Because they're perpendicular. Okay. Now here it says assume the lines that look tangent are tangent. So if we look here, it says find the value of x. X is right there. We have a triangle formed. Now this line is tangent, which means right here has to be right angle. So now all we have to do, if that's 58, that's 90, that's x. We know every triangle in the world adds up to 180. So 58 plus 90 gives us 148. Then just take 180 minus that 148. We'll get 32 degrees, and that is what x equals. Okay. Our next one. Once again, both these lines are tangent, which means I have a right angle here, right angle here. Now you might not know this, but if we have a four-sided figure, which we do here, 1, 2, 3, 4, much like a square, much like a rectangle, it's always going to be 360 degrees total. So in this case, we have 90 plus 90 plus 130. If we add all those up, we get 310. Take that 360 minus the 310, and we are left x will equal 50 degrees. All right. So that's how we can find those angles. Now sometimes instead we want to find side lengths, and in this case we look here, it says find the value of x. Okay, once again, if that's tangent, we know this is our right angle. When we have a right triangle, hopefully you guys remember a squared plus b squared equals c squared. So I can do 7 squared plus x squared. The 25 has to be c because it's the hypotenuse, it's across from the right angle. Okay, so 7 squared gives us 49. 25 squared is 625. Once again, use a calculator if you need to. We subtract 49 over, and we're left with x squared equals, let's see, that's going to be 576. All right, at this point, we can take the square root of that. If you don't know it, actually, let me use the calculator you guys have. So desmos.com/scientific. We don't know it over here. This is just square root of 576. We hit enter, 24. So it comes out nice for us. X has to be 24. And our final one, same deal. Here's another right angle. Same thing. In fact, some of the sides are the same. Even the 25 squared will still be 625. So when we subtract that 36, we have 591. Let's see, did I do that right? No, I did not. Sorry. Let me fix that. So when we subtract 36, we'll have 589. Trying to go too fast. Okay. And when we take then the square root of 589, hit enter, and you'll see here that we are going to, oh, I'm sorry. I am moving too quickly. Okay, let me fix something here. I put 6 squared as the side. 6 is the distance from the center to the edge. That whole thing, if we know from the center of the edge is 6, then from the center of the other edge would also be 6. So that whole thing would actually be 12 squared. So I was moving way too quickly. I apologize. So if we think about it then, we over here will have a 12 squared. So that'll be 144 plus x squared equals 625. All right, so now from here, subtract that 144 minus the 144, and we'll have x squared equals, so now all we got to do, so 625 minus the 144, it gives us 481, and then we're going to need to take the square root of that. So sorry, I was moving too fast. Square root of 481, we will get 21.9 degrees, or sorry, 21.9. And it doesn't say, but let's just get in the habit, round to the nearest tenth. So in our case, 21.93 rounds down to 21.9. If it specifies, we want to do what it specifies. Okay. So now, just about done. One more thing. It says, if two segments from the same exterior points are tangent to a circle, then they are congruent. So exterior point means a point on the outside. And you see how like RS, they both start at S, TS, they both go through S. So from T to S and R to T would be equal. Okay. So if you want over here, you could say like RS is equal to TS, meaning if there's no mark above it, that means the distance from R to S is the same as T to S. So in example 11 here, AB and AD, we'd set those equal. X squared plus 24 is going to equal 49. Subtract the 24. We'll get x squared equals 25. Square root of both sides. X will equal 5. Okay, we're almost done. The last one of today. Here we know these two are tangents. So they both go from that same point. So 2x plus 13 will equal 4x minus 8. All we have to do now, let's add 8 to both sides. Then we'll subtract this 2x. We'll get 21 equals 2x. Just divide by 2. Divide by 2. X equals, it'll be 10.5 as our final answer. So don't forget, there's a It's Learning assignment. Please get that done today. And if you haven't done the test, do that as well. I hope you guys have a great day. And let me know if you need anything or need any help. Bye.